Okay, I think we'll go ahead and get started. Welcome to our 2013 Crustal Deformation Modeling Meeting online tutorial. This is Brad Agard, and Charles Williams is also online. And here we are. We'll be joined later by Matt Nepley, who's at the University of Chicago. I'm in the United States at U.S. Geological Survey in Menlo Park, California. Charles is at GNS Science in Lower Hutt, New Zealand. And we are the authors of Pilot, the modeling code we'll be discussing. And we'll be discussing sort of some the codes that we use as pre-processing information in Pilot, as well as visualization software. This is an outline of the sessions. We're going to do 6 two-hour sessions. So today we have, in our first session, we'll give this brief introduction. Then we'll look at sort of a review of Qubit, Pilot, and ParaView. Then we'll go over sort of what's coming in Pilot. I'll do a quick demonstration of Qubit, Pilot, and ParaView that we've done in some of our other tutorials as sort of a refresher, because I know not everyone has been able to participate in previous workshops. We'll finish with a Q&A at the end of this first session, and then we'll take a couple-hour break, and then we'll come back, and Charles will present some meshing strategies in 2D and 3D, including how to specify complex variations in cell size using some recently added features in Qubit. We'll also have a question and answer session at the end of that session. On Wednesday, we'll come back and talk about Green's functions, how to compute them using Pilot, and this is for when you have complicated variations in physical properties and can't use simpler codes. Pilot, we've set up a relatively friendly user interface for Green's functions. On Wednesday, the second session, we'll be looking at solvers, and Matt Nepley will present information about options and choosing correct parameters for both the linear solvers and the nonlinear solver. Those are features in PETSI, which is one of the pieces that goes into Pilot. On Friday, we'll talk about how to use the fault friction within Pilot. It's one of the more complicated features within Pilot, and we've been getting a lot of questions, so we hope to get people up to speed so that they find it easier to use the fault friction interface and features within Pilot. And then the second session on Friday will be talk about running Pilot in parallel, both on a desktop as well as a cluster. And we'll aim to end all these sessions with some Q&A. We can also try to address questions as they come up. And so we ask that you enter all your questions into the Q&A panel down there in the lower left. And when we switch into the Q&A session, we'll sort of change we'll make it easier and give you a bigger panel to enter any questions. Sort of some notes on using Adobe Connect. We have the microphones enabled for the presenters, but the participant microphones are muted by default. That's to cut down on bandwidth and prevent people from sort of talking over each other. We find that in our previous experience that if people type the questions in the Q&A panel, then we can sort of accumulate, and the person not presenting, the instructors can actually answer those questions and see them as they come up. We can, especially in this sort of Schedule B where we expect to have sort of fewer people, we can unmute your microphone if it makes it easier to address questions. So the chat pod or the chat panel there on the middle left is where it's easiest to sort of enter in sort of feedback, short answer, or short information, such as things about if all of a sudden our audio cuts out or something like that. And then, you can type your whole question in there in the Q&A panel. And at the end of each session, we'll extract the questions and answers and update that on the agenda page. There'll be a link to the Q&A. And the slides for this session have already been uploaded to the agenda website. So if you have trouble seeing them in Adobe Connect, you can also download the PDF directly from the agenda. Adobe Connect is not perfect, but it works pretty well. We may run into an occasional technical issue. Usually it's related to audio. So either the audio gets delayed or it cuts out if we start using too much bandwidth. One advantage of having instructors in multiple places is that hopefully it only affects one of us and the other person will attempt to carry on. And we'll do our best to remedy any of these problems as quickly as we can. Just to give you a quick tour of Adobe Connect, we have this sort of layout where we have the main panel here with slides. We also have the ability to switch over to this configuration, which gives us a whiteboard that we can sketch on to help address questions. And then when we get to the Q&A session, we'll probably mostly be using this layout where there's more room for people to enter in questions as well as more room for the chat window. So back to our introduction here. In terms of getting help, the best way to get help is to read the pilot manual and try to work through the problem on your own. Generally, you'll learn quite a bit by trying to solve the problem yourself. Whenever you get stuck, you can send an email to CIG-short@geodynamics.org. That's our mailing list. Please describe the problem, and if you're trying to fix some sort of or deal with some sort of error message, send the complete error message and include the platform you're using, which pilot version you're using, whether it's a binary package or you built it from source. And we'll do our best to respond to questions. And feel free to email them in at any time as you're working in between sessions or after the workshop. We may not respond during this workshop. Our time is relatively limited because we are running two scheduled of the sessions and dealing with other work-related issues. So we may try and address some of them during the next online session for your particular schedule. Subscribe to the CIG-short@geodynamics.org. There's a link there from our pilot, from the CIG website as well as our pilot user resources webpage. And we do our best to CC the list whenever we get questions. And it's not a high volume list, so you won't be peppered with too many emails. There might be a little more traffic this week because we are running the tutorial. For those of you unfamiliar with CIG, CIG is a U.S.-funded is funded by the U.S. National Science Foundation. It is a virtual organization in many respects. The website is geodynamics.org. It has the objective of developing, supporting, and disseminating software for the geodynamics community. The goal is to develop have a coordinated effort to develop reusable, well-documented, open-source geodynamic software and form strategic partnerships with the larger world of computational science and geoinformatics to really leverage state-of-the-art software development and numerical techniques, and provide specialized training workshops for both the geodynamics and larger earth science communities. And the underlying principle is that earth scientists need help from computational scientists to develop state-of-the-art modeling codes. And that has certainly been the case with Pilot, with having Matt Nepley involved in the development. CIG is an open organization. Any institution, either within the U.S. or outside the U.S., seeking to collaborate in the development of open source geodynamic software can participate. There's no cost or size requirement, so you can join even as a single member from an institution. Currently, there is over 50 member institutions within the U.S., as well as 10 foreign affiliates, and our current funding runs through June of 2015. So another 2 years of funding. There are several different working groups. There's the short-term Tectonics or short-term Crustal Dynamics working group. It's gone by both names. That's the working group we're associated with. That primarily deals with earthquake and volcanic deformation. There's a long-term Tectonics group that tends to look on, that's long-term for longer time scales, so hundreds of thousands to millions of years. There's a mantle convection working group, a computational seismology working group that primarily focuses on the wave propagation, both regional and global, a geodynamo working group, as well as a magma dynamics working group. In our short-term Tectonics working group, our objective is to simulate crustal deformation across spatial scales from about 1 meter to 1,000 kilometers, and temporal scales ranging from a fraction of a second, associated with some of the fastest slip processes or time scales of an earthquake, to the order of multiple earthquake cycles reaching about 10,000 years. This working group was originally formed through efforts by Brad Hager and Mark Simon before CIG started. Since then, I have taken over as sort of leader from Brad Hager for this working group. Brad Hager and Mark Simons do continue to participate in some of our workshops. There's a strong connection through various groups within SCEC from where many of the original members came from. The current focus group within the Southern California Earthquake Center, or SCEC, is the Stress and Deformation Through Time, with a nice little SDOT abbreviation. And there's also the Fault and Rupture Mechanics group within SCEC that continues to participate in our efforts. CIG has a staff of software developers. There's a director that handles day-to-day decisions. The efforts of the staff are primarily driven by the Science Steering Committee, which is the voice of the geophysics community that prioritizes the competing needs of all these subdisciplines to help prioritize what software is developed by CIG, and in collaboration with the community. There is an executive committee that takes those decisions and comes up with the final funding recommendations to the director of CIG and makes the contractual arrangements. The member institutional representatives vote on membership applications and bylaws, and the community members are primarily collaborate with staff to develop the software, as well as get help in how to use the software. Software development is the primary activity. The second activity is generally workshops that are organized by one or more working groups. Some of these workshops focus on scientific communities, but most of them focus on one of the subdisciplines, such as the one we're holding this week. And we also have in-person workshops in even-numbered years. We provide training in the use of CIG software through tutorials at in-person workshops or various national meetings, as well as specialized training sessions like this one. The website geodynamics.org distributes the software and documentation. There's mailing lists for each working group, and geodynamics.org generally is a website that allows people from the community to participate and edit web pages. Here's covers from various manuals within the CIG software. You see Pilot and Gale. Pilot is for sort of our short-term tectonics, Gale for longer-term tectonics. Pilot has elasticity, Gale has everything is viscous. There's the mantle convection code SITCOM-S, some benchmarking software that has sort of reached the beta stage called Sigma, MAG for the Geodynamo, Minios, SpecFem, SpecFem 3D are all computational seismology. Relax is a code developed by Sylvain Barbeau, who is now at EOS, Earth Observatory of Singapore, that handles layered and simple variations in material properties for the earthquake-related problems and viscoelaxation. And then there's this FlexWind program that's used within the seismology community for windowing software, windowing sort of seismograms, sorry. So Relax solves 3D problems associated with earthquake faulting and quasi-static viscoelastic deformation. It's primarily for use in a homogeneous half space where the geometry does not change significantly. And by using sort of semi-analytical approaches, it can compute the response using just sort of a fraction of the computational resources that Pilot generally needs, because Pilot is a fine element software for 2D and 3D problems that can handle much more sort of complex geometry from faulting and viscoelastic deformation, as well as nonlinear rheologies. It includes, it also is restricted to problems where the geometry does not change significantly. So that would be sort of evolution of fault systems or evolution of topography. If the geometry does change significantly, then Gale is the code that comes into play. It solves problems in orogenesis, rifting, subduction, includes coupling of free surfaces to surface erosion models, and as I said, it takes over where the geometry changes significantly. So those are the three main codes in use by the short-term and long-term tectonics community, and that gives you an overview of the CIG organization as well as some of the software being developed.